Hey everyone, I just got a call from a student asking about section 5.1, problem 1. And I, I think I would like to share what we did together with you all. So her problem was that the function in WebAssign is f of x equal to 3 cosine x for x between 0 and pi over 2. The problem says that she should subdivide the integral in 4 pieces of equal length and then use the right endpoint rule to compute or to estimate the area under the curve. So then I went with her through the formula, what the right endpoint rule is, how to use it, and how to set up the estimate. So that's what you find here, right endpoint rule. So that is this piece here and this piece here. Look at it. If you have a problem understanding it, please give me a call. But this is a very essential, a very important problem. Huh? It's important for you to notice that it's really of no significance at all if f of x is equal to 3 cosine x. So whatever f of x is, the setup is always the same. The only thing that changes then is this piece here. Depending what f is, the formula here changes. But as long as you know how to use a calculator, that does not make any difference. The important thing is in the end how to compute this sum. And in the Stewart textbook and in the WebAssign homeworks, they really want you now to sit down and figure out what this number is, what this number is, what this number is, and what this number is, and then type these 4 numbers in a calculator, sum them all up, and multiply it with pi over 8. And that is horrible, because at the end we don't want to do it for n equal to 4. We want to do it for n equal to 100 or n equal to 1,000. So we want to subdivide the interval in many more pieces than 4. And there, the method of evaluating all these numbers, these 100 or 1,000 or million numbers, and then adding them up is just not efficient. And for this, it's not important that you watch the video that I posted, the YouTube video, how to compute sums. And I think the guy in the video, he does it from 0 to 10. But there is no reason to go from 1 to 10. I could also go from 1 to 20 or 1 from 100. Nothing changes, just the sum. You add more and more things up, but the calculator can do this as easily. So please watch this video. And then when you do this video, I have here a more complete picture. Again, it's f of x equal to 3 cosine x for 0 and pi over 2 as the bounds. And if you do the right endpoint rule that was asked for in the problem, you should get, with n equal to 4, you should get 2.37. The left endpoint rule should give you something like 3.550. And if you take the average of this is then the trapezoidal rule, which is usually a much better estimate for the area. It's then 2.96. And then if you do the same thing where you divide the interval not in 4 pieces, but in 100 pieces, and you do the same problem, you should go 2.97, 3.02, and 2.999. And finally, we want to know if our results are somewhere in the ballpark, so we have to check it. There are 2 checks. One is you have to learn how you calculate to compute an integral. And if you do this in your calculator numerically, the calculator gives you 3, which again shows that these are good estimates, these are good approximations. In the second check, this is what we cover in the next section, is the fundamental theorem of calculus, which says if you have a function, in our case 3 cosine x, you compute an antiderivative. In our case, an antiderivative of cosine is the sine, so it's 3 sine x. You could add here a constant, but since I can take any constant, I may take as well the constant equal to 0. And then the fundamental theorem of calculus says that if you want to evaluate an integral, You just compute the antiderivative of the function, the capital F, and plug in the upper bound minus the lower bound. And since the sine of pi over 2 is 1, you get here 3 minus 0, so which is 3. Anyway, this is a comprehensive solution of problem 1 out of section 5.1. Enjoy the other problems. Talk to you tomorrow. Thank you. Bye.